everyone, my name is Jasmine Aulia Santoso with student ID F1D02410010. So in this video, I will present my project entitled Sentiment Analysis on IMDb 50,000 Reviews using PySpark, with a focus on comparing the performance of 4 core operations, which are map, filter, reduce, and query. In addition, I compared the performance of PySpark with additional pandas processing. So first, I initialize both Spark Session and Spark Context. Spark Session is used for SQL queries, while Spark Context is used for RDD-based operations such as map, filter, and reduce. The IMDb dataset is downloaded directly from Kaggle using the Open Datasets library. After loading the data into a Panda data frame, it is converted into a Spark data frame so it can be processed in a distributed environment. So we go to the map filter. The first stage is the map operation. In this stage, I perform 4 pre-processing tasks simultaneously, which is first text cleaning, converting text to lowercase and removing HTML text, and then stop word removal, removing the common words such as D, is, and N that do not contribute meaningful sentiment, and then stemming, reducing words to their root forms, and then the fourth is word count calculation to count the number of words in each review. These operations are implemented using the RDD map function and executed in parallel across all 50,000 reviews. And then this is the result of the map operation. So we go to the filter stage. Here I divide the process data into 4 categories, which is positive reviews, negative reviews, long reviews containing more than 100 words, and then strong opinion reviews containing highly expressive words such as excellent or terrible. The filtering process is implemented using the RDD filter function. And then we go to the reduce operation. First, I calculate the total number of reviews using the reduce function. Then I identify the most frequently occurring words in positive reviews, negative reviews, and the entire dataset using a combination of flat map and reduce by key. And here is the results. The results are quite interesting because the words in positive and negative reviews are kinda similar. So we're gonna move to the Spark SQL queries. The process dataset is registered as a temporary SQL view, allowing us to perform analytical queries. So I execute 4 SQL queries, which is sentiment distribution, and then review length statistics, top 5 longest review, and then sentiment percentage calculation using a window function. And here is the results of the queries. And then we're going to the most important part is benchmarking. So here I measure the execution time of the map, filter, reduce, and query operations. Each operation is executed 3 times. And then the result shows that the map operation is required the longest execution time, approximately 137 seconds, because it performed multiple text pre-processing tasks including cleaning, stop word removal, stemming, and word count calculation. Filter and reduce operations were significantly faster because they involved simpler computation, while Spark SQL query achieved the fastest execution time due to Spark's internal query optimization mechanisms and the relatively small aggregated output. And then I also compare the Pandas and PySpark performance. For a dataset of 50,000 reviews running on a local machine, Pandas can sometimes perform similarly or even slightly faster due to the overhead associated with distributed pre-processing in Spark. The advantages of PySpark become much more significant when working with substantially larger datasets or distributed computing clusters. And then, in conclusion, this project demonstrates that each PySpark operation has different performance characteristics. Filter is the lightest operation, map is the most computationally intensive due to the preprocessing, reduce requires aggregation and shuffle operations across partitions, and query introduced optimization overhead but provides powerful capabilities for complex analytical tasks. So that's all from me. Thank you for watching.